Really, in the UK, we are very hamstrung in what we can do.
Buildings going up in Japan that are like 40 stories in timber, which has got earthquakes and all sorts of stuff we don't have here. And it does get cold there.
If your top floor is above 18 metres, timber's gone.
I don't get it. I think it's an overreaction. I think there needs to be more work on it.
Welcome to another mini episode of Urban Forecast. These special episodes that are just me and John reflecting on what we think about some of the challenges in the industry. And this week, the topic is, are the building regulations in the UK killing net zero? So this has come from a bit of LinkedIn-ery again. I posted about how I thought that embodied energy was a silly thing to worry about and we should only care about operational energy, and I was then schooled by quite a lot of people who made a point about the immediacy of embodied carbon in buildings, and actually the fact that you're making such an impact now and it carries on for future generations. And then in response to that, I thought, well, really in the UK we are very hamstrung in what we can do often as architects in terms of specifying low embodied materials. Because anything above 18 metres, we're really, we can't use anything organic or natural in the structure, in the walls, in the slabs. So that really started my mind thinking about, who do we need to lobby to get get the building regulations changed? Because if we are going to try and deliver housing at scale and also get to net zero, these two is a round peg in a square hole. We're going to have to work it out somehow.
Couldn't agree more, and I think it is a real challenge. It's not just building regs, is what I'd say. It's like the industry generally. So, the Building Safety Act, but then also insurers. So we've had a problem on various schemes where it would comply with building regs by jumping through various holes, but then you can't get insured, or it's not mortgageable. So there's a lot of general fear, and I can't totally understand all of it where it's happening on the continent. You see buildings going up in Japan that are like 40 stories in timber, which has got earthquakes and all sorts of stuff we don't have here. And it does get cold there. So it's not, but here we seem to think we're sort of a bit reactive. And I do think, Grenfell's one of the greatest, modern tragedies in the UK, and we have to learn from that. But kind of flammable insulation that was lied about on a concrete frame, with a bad stair strategy and many other things that went wrong. But does that result in us not being able to use timber? It seems like a sort of not the quite right deduction. I think we've got to kind of take the lessons learned from the horrific tragedy that happened, but also not kind of learn the wrong things from that. And I don't think timber was a component of that tragedy really at all.
No, it wasn't at all, but it seems to have been the one that, the material that has lost out the most. So in terms of the different, I suppose there's to my mind, there's kind of different thresholds for where you can and can't make easy wins in embodied energy. So I think if you're talking about a kind of 2-story house, then you, from inside to out, could make that building out of timber, right? You could have cross-laminated timber sort of structure, which would then also be your internal wall, and then you could put timber insulation on the outside like we did on Bessemer, and then timber cladding, and that would be an amazing timber inside to out build up. But you've still got the fact that you've got quite sort of highly cementitious foundations going into the ground.
But the amazing thing about timber is it sequesters carbon. So the trees that are grown, if they're grown in the right way, do suck carbon back out of the atmosphere. So if you're doing what I would advocate, which is trying to retrofit, as much as possible, but then use timber systems, then it can work well. I guess the problem with timber, it can rot, so it's making sure that it doesn't and doing it in the right way and being clever about it. But I think you will need some concrete and things to make it work, and bits of steel, but majority of it can be timber. And if you're using timber from a decent source, then I think you can probably end up with an embodied very low or neutral embodied carbon energy. I think there are some buildings with some practices that have achieved kind of what they consider is they're actually putting back. Now, whether or not there's some question marks about how you actually calculate that, but in theory, it'd be amazing if you could build buildings that were better, that reduce the carbon footprint as a
So would that be like a screw pile system for the foundations and then kind of beams above the ground, so you're almost doing a sort of timber beam floor?
So we did a carbon analysis back when I did the technology strategy board back in the day, government funded research. We looked at school Bessemer. Me and both of you worked on that at some point. So that did have a concrete sort of piled traditional in a way slab. So that if you could reduce that, great. The loads on timber are lower than the concrete frame, etc. So that is good. But yeah, then you do a timber frame building, timber insulation. You can do different types of cladding. I mean, even if you want to put non-combustible cladding on the outside, there are some systems now where you kind of build the inside frame in timber and then clad it in something else. So that
hold your horses. We're not there yet. So that is 1 or 2 or 3 stories. That we've got a decent strategy. We try and reduce the size of the foundations. We do mass timber or timber frame. We protect it if it's a timber frame, but if it's just mass timber, I don't think you need to protect it. And then we can have timber build up on the walls inside to out. When we go above 4 stories, above 11 meters, then we're going to have non-combustible wall build-ups inside to out.
Yep, on the outside face, you can have some timber on the inside in the current regs, as far as I understand it, and
you can have timber in the wall structure.
What happens is you end up, because we've been looking at a couple of systems where you end up having a kind of metal system on the outside. It's the external wall build-up that has to be done.
Yeah,
but it seems a bit like there could be a bit more flexibility there, done in the right way to allow that. I don't, having a bit of mass timber in the external facade, personally, if it chars and is checked by a fire engineer, could be a solution. But,
we've just done a building, because you can't have it as a structure, can you? Or is that
I
the
think
next
you
one
possibly can. And I don't know the answer. I think we actually, I don't mind talking about, I think we probably need to talk to get in there with some good engineers that we're working with and just understand. But one of the problems is when you go above a certain height, there's this thing called progressive collapse, and you end up having to introduce steel and concrete to prevent the whole thing falling down. It's quite hard to justify in any other material in the current codes other than steel and concrete. So you end up having to introduce a sort of steel frame of sorts in there. And so even if you have bits of mass timber in there, you're kind of fighting an uphill battle. You're making
so we've just done that at Old Street, which is just completed now, and that's got a steel structure sort of internally, and then it's got almost like curtain walling on the facades. But the floor slabs are all timber, which is nice because you get that exposed soffit in the office spaces, and the sidewalls are as well. But they're not really structural. They're not the primary structure, as you say. If in case of a collapse, it would be the concrete core and the steelwork that would actually stop the building from falling down. So that's like the sort of middle ground. And then in a residential space, if the top floor is above 18 meters, timber's gone.
Yeah, so that's got to be challenged. I think there's a lot of things. I think there are people challenging. It's definitely happening in Europe. There's people building over that height. Definitely happening in Japan, North America. So I think, I don't get it. I think it's an overreaction. I think there needs to be more work on it.
I think this probably kind of leads us on to another point, which is definitely worth discussing, which is that obviously there should be the building with the lowest carbon to create is the one that's already here. So we sort of jumped that stage, but retrofit versus knockdown rebuild is always going to have lower embodied carbon.
No, exactly. I was about to say with your post that you got slated on, I should have been one of those people. I was like, what are you talking about? Retrofit first, for me, always makes sense. The problem is it's hard to retrofit. And actually, I think one of the challenges to think about is how we design so that it's a 70s saying, but it's a very true one, which is long life, loose fit. So you can repurpose those buildings. So I do believe that in that case, concrete is quite a good material, although it's got a very high embodied energy, and some environmentalists will shoot you. But there's when you get a big concrete frame, you can reuse it sometimes, and steel frames can be reused. Probably a mass timber frame could be reused and repurposed in different ways. But it's about understanding that. So I do think there's a kind of obligation on us to make it kind of more easy to dismantle and reconstruct different bits of buildings.
Do you want to talk a little bit about the retrofit project that you're doing in Camberwell Magistrates Court, because that's reusing a huge amount of concrete?
Yeah, so that's it's a big 1970s concrete frame building, double basement, kind of 11 meters deep, and the original scheme, previous firm working on it, we're looking to take that down, get as much height as possible, big site, island site. And when we kind of reapproached it with the developer, came back with an idea of keeping all of that, stripping it all off, and then rebuilding it. There's thousands and thousands of tons of carbon in there. So I think that type of approach can work quite well. And I think probably the obligation thinking forward is how we can also make our buildings more adaptable to do that. So 1970s concrete work, if we're now going to go on the timber revolution to make everything CLT, then think about how it's demounted. And I think we had a really interesting podcast, didn't we, with Steve Gilchrist, I think is his name, from Circular Steel. And he's got some of the big kind of, I can't remember which, some of the big estates in central London are now trying to recycle steel using standardised sizes, kind of getting that. And I think there's something really in that. And it actually, I think sometimes can create more interest. It's just slightly...
Definitely. I thought it was quite interesting that his initial point about steel was that it's always been recycled because it's too valuable not to. So it's just, can you reuse the beams? Like the typical way that it will be done is that, whatever. If the base state is it gets melted down and made back into steel. The next, that's obviously the least preferential, but slightly better than throwing it away. The next best was to cut off the joints at either end and use the middle bit, and that apparently is reasonably common. And then the ultimate panacea that he was aiming for is actually just unbolting it and using the whole thing again. But obviously, that's giving you quite a lot of constraints.
We end up having to oversize the steel was one of the things I found. You to try and make it a standard size, you kind of have to make it bigger and blah blah blah. So it does get complicated. But
it sounds incredibly hard.
That's the problem. The world of just throw it away, get a new one.
Yeah, exactly. If my iPhone charger doesn't work properly, I throw it away and get a new one. Shouldn't say that. John, thank you very much. That was a brilliant little short episode.
Cheers, Ollie.